Hi, everyone. It's good to see you again. I think I just saw you a few hours ago. My name's Josh. I'm on the React team at Vercel. And this is a deep dive talk where I kind of go into deeper detail about some of the stuff that I talked about earlier today in the keynote. I've been a fan of React for a really long time. In fact, I was here in 2018 and 2019, sitting somewhere. Actually, we were over there, but it's really cool to be up here now twice today. And I really am excited to share with you kind of what I've been working on inside React and get into some kind of the decision making that we made. All right, so let's begin. So in React 19, we added a number of things that help you compose non-visual HTML alongside visual HTML. You can render document metadata, style sheets, async scripts directly from components and still expect React to produce an HTML document with these elements in the ideal position. And in this talk, I want to talk about those design challenges that we had to solve. But I have to still recap the problem, so we're going to go through that fairly quickly since some of you might have already heard it before. But in React, you often want to be able to reason about your components locally, and this means that you can understand what the component's going to do without having to understand everything else in your application. But it's hard to write components like this article example. This component's going to render its article contents, but it also wants to render the page title. And it wants to load a style sheet that should kind of alter the visual presentation of the article. But if we actually rendered a component like this before React 19, the page title and the style sheet are going to be somewhere that they shouldn't be. They're going to be deep within the body, and we really want them to be in the head. Now, to solve this problem, you really just have to kind of give up on co-location. There's not really like a good solution for this, and you kind of have to move the coordination of the styles you want to load or document metadata into some other system that sort of lives outside of React. And users often turn to libraries and bundlers to solve this problem for them. And so while you may not directly interface with this sort of coordination challenge, the people who write these tools do, and it can be quite painful. We want React to better support libraries and bundlers by eliminating this coordination work, but we also want to make these things work better with built-in React features like suspense and streaming. Okay, but rather than actually going through each new API and kind of just rehashing what they do and how they work, instead I want to talk about why you would even care whether the HTML was sort of in a particular location. What are the motivations for us even wanting to do this in the first place? So the first one I want to talk about is tool compatibility. Most of the time, when you produce an HTML document, it's for some person, and they consume it through a browser. And browsers are really good at finding and using things like document metadata, even if they appear somewhere that they're not really supposed to. But sometimes HTML is consumed by bots or other tools. Facebook's or Meta's Open Graph Image Processor is sort of famous for this, where it only really looks in the head. And so you have to be kind of quite careful about how you describe Open Graph properties to make those work on social media sites. So we decided we'd take a pragmatic approach. If the spec says something should go in the head, then we try to put it there. And often we can. But React also believes that streaming UI can provide a better user experience than traditional server rendering. And we need to confront the fact that when you stream, you don't always know that you're going to discover something that should go in the head until after you've sent it. So when React discovers document metadata after the head's already been written, it simply emits those tags into the body. When preparing an HTML document for a live request, with a person on the other end of the screen, we favor showing something useful early, and we rely upon the browser to just sort of tolerate late arriving HTML. And the way that you tell React that you want this behavior is you just start reading the HTML as soon as possible. But maybe you're pre-rendering and you intend to cache this document for future live requests. You don't want to include every intermediate UI state. Or what if you determine that you're preparing a document for a bot or some other tool that doesn't interpret HTML as flexibly as a browser? You can ask React to ensure the HTML is complete with no intermediate states, and simply wait for React to finish rendering before you read the document. And that's what we mean when we say balance. You have the levers to pull depending on your circumstance. That means you don't have to sacrifice raw performance for live users while still being able to produce clean documents that are compatible with tools that require stricter adherence to the spec. And if you're skeptical, go look inside the HTML from your favorite product on Amazon. The largest e-commerce company in the world is happily rendering titles and descriptions deep within the body because it's pragmatic and it works. All right, the second thing I want to talk about is loading speed. Fast sites are good. It's not particularly controversial. And one of the best ways to make a site load fast is just to make sure that the first tags that the browser encounters are, the ones that describe all the resources that it needs to complete loading the page. Scripts don't have a visual component, so we could, in theory, put them anywhere in a document. But unfortunately, they have a pretty serious downside. They pause all HTML parsing while loading, and then they execute synchronously. React can't just relocate normal scripts because this document order constraint might be relied upon. But even if we could come up with some way to work around that, we'd probably make the page performance worse if we moved it earlier in the document. But if you can switch to async scripts, you probably should. And once you've made your scripts async, React can safely relocate them and include them earlier, both on initial load and during streaming updates. Another consideration for loading quickly is to eliminate waterfalls. Imagine you have a style sheet that has, uses a font and has a background image embedded within it. These resources aren't represented in the HTML directly, and so the browser's not going to know about them until after the style sheet's loaded. We can provide a hint to the browser by rendering preload tags. However, rendering isn't the only time that hints like this would be useful. For instance, you may want to start preloading on navigation intent, like a link hover. But there's no rendering going on here. So instead, we modeled hints as side effects using an imperative style API. And you can use the same composable API from within your components as well. So far, all my examples for resource hints have been about preloading. But here's a list of all the browser hint functions that are added in React 19. Prefetch DNS and preconnect are interesting because sometimes you don't actually know what resources you're going to load, but it'd still be useful to establish a connection early because you know the host that you're going to actually connect to. Pre-init is a lot like preload, but you actually want to have the browser actually start using the resource early. If you it takes time to parse style rules, so maybe you want the browser to actually go through that step so that later when you need to use those styles, it's a little bit faster. And Webpack chunks are another good example where parsing the chunk can make the loading feel faster by moving this work earlier in time, so it actually loads the script rather than just preloading it. We also support ESM as well. You'll notice there's preload module and pre-init module as well. These are there for people who are living in the future using the ESM for all their stuff. All right, the last important consideration for faster page loading is prioritization. Browsers can only do so much concurrently, and so even if we get every hint possible to arrive early, we still want the most urgent ones to be encountered first. When considering what work needs to be done to get pixels on a screen, resources that block paint should be favored over those that don't. So React will ensure that fonts, high-priority images, and style sheets are all loaded early. But we also want to make sure that we're taking advantage of any early connections. So React ensures those actually come first, and it ensures scripts and other preloads arrive last. This looks like a pretty good prioritization, but there's a few things that are still missing that I think really show off the power of letting React do this coordination. Let's consider the char set meta tag. It's a little strange, actually, that we even need to render this in HTML, but unfortunately, it still kind of matters today. If you render a char set, it really needs to come first because it tells the browser how to decode the rest of the document. And image preloads can be affected by viewport size. So React ensures that if you render a viewport meta tag, it always precedes any preloads so you never end up downloading the wrong size image. And finally, import maps affect ESM module resolution. So when you render an app with an import map, React makes sure it precedes scripts that might otherwise load incorrectly. All right, the last motivation I want to talk about is style coordination. Style sheets are sensitive to the relative order because rules in later style sheets override rules in earlier ones. But being able to coordinate the relative position of style sheets across components is a difficult problem. We actually considered briefly whether we should just recommend style systems not rely on precedence to work correctly, but we knew that we'd leave a lot of users behind if we actually did this. So instead, you tell React what the precedence is. This is both an opt-in to the new style sheet mechanics, but it's also an instruction to React on how to manage the style sheet order correctly. Many of you will be just fine using a single value like default, but for those of you that need more control, you can craft a precedence hierarchy that works kind of like how CSS layers do. But I think the really interesting thing to consider with style sheets is actually the consequences of global order. Browsers do this really cool thing where style sheets in the document head always load before it does the initial pane. It's pretty basic sounding, but it's so critical to having a good experience when you first open up a page. You don't want visual bugs like flash of unstyled content ruining the day. But just like with document metadata, we have to contend with the trade-offs imposed by streaming. When you stream with React, we don't have guarantees that every style sheet will be discovered before we've sent that initial HTML. So React extends the built-in behavior of style sheets discovered during streaming and makes sure that they are always revealed in coordination with UI. When you render a style sheet with a precedence prop, the nearest suspense boundary will not be revealed until that style sheet has loaded. Now, I've actually been a little imprecise in my language. I keep saying the word style sheet, and you're probably all imagining a link tag pointing to some CSS file that loads over the network. But that's only half the story. That's right, I'm talking about CSS and JS. Now, calling it suspense for CSS and JS, it might sound kind of strange. These styles are style tags. They don't actually have to fetch anything over the network. But one of the most difficult challenges with CSS and JS implementation in React right now has to do with streaming server-side rendering. When a suspense boundary is about to be revealed on the client, it's critical that all the styles that were used in that boundary are already loaded in the browser before React sends that instruction. And if you've ever looked into how you'd accomplish this today in React, let me just tell you, it's a mess. Just like with the style sheet links, React needs to know about the precedence of the style tag, and it needs a unique ID. Now, the reason we call this unique ID href was that we originally built this capability for a kind of unrelated feature. We wanted to make React be able to inline style sheets so that we could make some renders, single round trip. We don't have to go back and fetch additional resources. And so we just take a link to some external style sheet, inline those rules right in the document, and call it a day. But it turns out that this model works pretty great for CSS and JS too. Once CSS and JS libraries adopt this method of encoding rules, all the complicated code it takes to intercept the HTML stream and ensure the rules arrive before the content can simply be deleted. This will improve the internal implementation of these libraries, but it'll also allow the removal of difficult to understand APIs that you have to use if you want to use these in server-rendered environments. There's one last thing that I want to share about style sheet coordination. For many developers, styles are managed by their bundler of choice. But bundlers often do their own style coordination to prevent visual bugs. So when you load a new chunk from your bundler asynchronously, the module will not be made available until after the style sheet has loaded. While this is good for correctness, we have the opportunity to speed things up. By leveraging React's new suspense for CSS capabilities, the resource load can be done in parallel to the code execution, while still ensuring the UI never paints with incomplete styles. All right, so what's the point? React 19 is taking on a new kind of coordination challenge. These problems are hard to solve in user space, and we think React 19 has pragmatic solutions that balance the correctness and capability and support all of our runtimes consistently, and most importantly, allow you to write components that compose even when they contain HTML that is being used somewhere else, or that belongs somewhere else. And whether you use these new features directly, or you just use libraries that take advantage of them, the bottom line is that complex code somewhere gets to be deleted, and your component model is more powerful than ever. Thank you.
Ash on the mic, bringing the heat. React Conf 2024 can be beat.